Andrew Ng posted a map, 4 boxes, 1 central node, a clean hierarchy connecting what he calls AI engineering. The internet saved it, shared it, moved on. But this map is not a curriculum. It is not a skills checklist. It is a structural diagram of a handover. Every box on that map represents something the human engineer used to own. And every connection between them represents the path along which that ownership is being transferred. To understand what is actually happening, we have to stop reading this map as a list of things to learn and start reading it as a timeline of things being lost. The first node reads, Building and Deploying AI Applications. 6 years ago, this was a niche. You had model researchers on one side and software engineers on the other. The model people understood gradients, loss functions, and tensor operations. The software people understood distributed systems, API design, and infrastructure. The gap between them was enormous. Then something changed. Models became APIs. You do not train GPT-4. You call it. You do not manage weights. You manage tokens. The deployment layer collapsed into a request-response cycle. And suddenly, the skill of building AI applications was not about understanding neural networks. It was about understanding orchestration, retrieval pipelines, context window management, caching strategies, rate limiting, fallback chains, evaluation harnesses for non-deterministic outputs. The engineer who builds AI applications today is not an ML researcher. They are a systems engineer who treats a language model as an unreliable, stateless, probabilistic microservice. That is a completely different discipline, and it is one that most traditional software engineers have not yet realized they need to learn. But here's the problem. That skill, orchestration of probabilistic systems, is itself being automated. Frameworks like LangChain, LlamaIndex, and DSPy are abstracting away the orchestration layer. AutoGen and CrewAI are abstracting away the agent coordination layer. The distance between I want an application that does X and the running code that does X is shrinking fast. So Node 1 is not a future-proof skill. It is a transitional skill, a bridge between the old world and the next one. The second node reads Software Engineering Fundamentals. This is the one that sounds safe. Fundamentals, the stuff that never changes. Data structures, algorithms, system design, version control, testing, debugging. But look at what is actually happening to each of these. Data structures and algorithms were the foundation of computer science education for 50 years. The reasoning was simple. If you understand how a hash map works, you can choose the right one. If you understand Big O notation, you can reason about performance. But when an AI agent can implement a hash map from scratch in 3 seconds, and when it can analyze the time complexity of an entire code base faster than you can read a single function, the value of that knowledge drops. Not to 0, but to something close to the value of knowing how to do long division by hand in a world where every pocket has a calculator. Testing is shifting. When outputs are non-deterministic, traditional unit tests break. You cannot assert that a function returns exactly 7 when the function is powered by a language model that might return 7 today and 7 tomorrow. The entire testing stack is being reconstructed around evaluation frameworks. LLM as judge, regression suites for semantic behavior, automated red teaming. The engineer who only knows PyTest is already behind. Debugging is shifting too. When you wrote the code, you could trace a bug by reading the execution path. When an AI agent writes the code, you cannot trace the bug the same way. You did not make the decision. The model did. So debugging becomes forensic. You are not looking for your mistake. You are looking for the model's reasoning failure. That requires a completely different mental model. You are not debugging logic. You are debugging inference. Version control is shifting. Git was designed for human-authored commits. When an agent generates 400 lines in 12 seconds, the commit graph becomes meaningless. The granularity of human review cannot keep up with the velocity of machine generation. We are moving toward a world where the diff is not the unit of change. The specification is. So when Andrew Ng writes Software Engineering Fundamentals, he is not describing a stable foundation. He is describing a set of skills that are being structurally redefined in real time. The fundamentals are not disappearing, but they are being demoted, from the thing you do every day to the thing you understand but rarely touch. The third node reads, using coding agents. This is where most people stop thinking. They hear coding agent and they picture GitHub Copilot, autocomplete on steroids, a fancy tab key. That is not what a coding agent is. A coding agent is a system that receives an intent, decomposes it into subtasks, writes the code to solve each subtask, runs the code, reads the errors, fixes the code, runs it again, and repeats until the task is complete or it determines that it cannot be completed. The human does not write code in this loop. The human defines the task. The human reviews the result. The human provides feedback. But the human does not type the code. This is a fundamental inversion of the programming model. For 70 years, programming has been the act of translating human intent into machine instructions. The programmer is the translator. The code is the translation. The machine executes the translation. When you use a coding agent, the translation layer moves inside the machine. The agent translates intent into code. The human is no longer the translator. The human is the reviewer. This sounds subtle until you work through the implications. When you write code, you have deep, structural understanding of every line. You know why the variable is named that way. You know why the loop terminates at that bound. You know why the error is caught and silently logged instead of thrown. You know because you made every one of those decisions. When an agent writes code, you do not have that understanding. You have a result. You can read the result. You can test the result. But you did not make the micro decisions. And the aggregate of micro decisions is what we call architecture. The agent is now making architectural decisions, not at the level of should we use microservices, but at the level of should this function cache its output? Should this loop break early? Should this error be retried? Those decisions, multiplied across thousands of functions, are the architecture. And they are being made by a model that does not understand your business context, your users, or your system's history. So using coding agents is not a skill about tools. It is a skill about control. How do you maintain control over a system when the micro decisions are no longer yours? The answer, currently, is that you do not fully. You review, you test, you constrain. But the surface area of what the agent decides is larger than what you can verify, and it is growing. This brings us to the fourth node, the one that matters most, shaping the build. Read that phrase carefully. Not building, shaping the build. Building is execution. Shaping is direction. Building is writing the function. Shaping is deciding which functions should exist. Building is choosing the algorithm. Shaping is defining the problem the algorithm should solve. Building is implementation. Shaping is specification. Andrew Ng placed this at the top of the map, and in doing so, he quietly redefined what an engineer is. The engineer is no longer someone who builds. The engineer is someone who shapes what gets built. The engineer defines the constraints, the boundaries, the success criteria, the evaluation metrics, the risk tolerance, the performance envelope. The agent does the rest. If you want to understand how profound this is, consider what a specification looks like in this new world. It is not a Jira ticket that says, implement user authentication. That specification is too vague for an agent. A specification for an agent looks more like this. The system must authenticate users via OAuth 2.0 with PKCE. The token endpoint must return a JWT signed with RS256. The token must expire in 15 minutes. The refresh token must expire in 7 days. The refresh token must be rotated on every use. The system must reject any request with a token that has been revoked. The revocation list must be stored in Redis with a TTL matching the token expiry. The system must log every authentication event to the audit pipeline. The system must fail closed if the audit pipeline is unavailable. The system must handle 10,000 concurrent authentication requests with a P99 latency under 200 milliseconds. That is not a task. That is a contract, and the agent will implement it. It will write the code. It will write the tests. It will run the tests. It will fix the failures. And it will deliver a system that meets every one of those constraints. Or it will report that it cannot. The engineer's job, in this model, is to write the contract, to specify the system with enough precision that a machine can build it without ambiguity, and to verify that the result actually meets the contract. This sounds like power, but it is a specific kind of power. It is the power of an architect who never touches a hammer. The architect specifies. The builder builds. The architect is responsible for the design. The builder is responsible for the construction. If the design is flawed, the building collapses. If the construction is flawed, the building collapses. Two different failure modes. Two different skills. Gene's map is telling us that the engineer is becoming the architect, and the agent is becoming the builder. But here is what the map does not show. The map does not show what happens to the engineer who has never built anything, the architect who has never poured concrete, who has never hit a nail, who has never felt the weight of a brick. Can you specify a building if you have never built one? Can you write a contract for a system if you have never implemented one? The answer, today, is maybe. Because the engineers who are alive today grew up building. They wrote the code. They hit the nails. They have the tacit knowledge that comes from making every micro-decision thousands of times. They can specify because they have implemented. But the next generation will not have that. The next generation of engineers will grow up shaping. They will learn to write specifications before they learn to write functions. They will learn to review before they learn to build. And the tacit knowledge, the feel for what is hard and what is easy, what is brittle and what is robust, what is clean and what is a hack, that knowledge will atrophy. That is the real map, not a map of skills, a map of a transition, from builder to director, from implementer to specifier, from engineer to operator. And the node at the center of it all, the node that connects everything, is not AI engineering. It is the moment where the engineer stops engineering and starts managing the thing that engineers. Andrew Eng mapped the engineer. He just did not say it out loud.